Alright, welcome to Chemistry Goal 6 video notes. This is 8th grade science, Webster Groves School District. For this goal, students need to be able to demonstrate and provide real-world evidence that mass is conserved during a physical and a chemical change. So you talked about chemical and physical change in the last goal, and we are reviewing it in this goal and adding some things on. Okay? So in order to earn a 3 on this, you will need to demonstrate and provide real-world evidence that mass is conserved during a physical and a chemical change. You also need to be able to correctly apply the law of conservation of mass to a situation. Okay? In order to earn a 4, you will need to be able to look at a chemical reaction and use your knowledge of conservation of mass to figure out what the product would be. Okay, so the law of conservation of mass, or law of conservation of matter. This law states that matter cannot be created and that matter cannot be destroyed. So to break it down a little further, this means that the mass of an object cannot change even when a physical or chemical change happens to that object. The mass is never going to change. You could have energy created, or you could, break the matter into smaller pieces, or the matter could change states, but it's not going to change the amount of matter. In order to understand this, you're going to need a refresher on what mass is and what matter is. Okay, so if you have forgotten, mass is the amount of matter in an object, and matter is anything with a measurable volume or mass, anything that takes up space. Okay, so quick video showing physical changes on an object, but even though physical changes are happening, it's changing shape, it's changing what it looks like, but mass is still conserved. So matter is not being created, matter is not being destroyed, it's simply changing shape, and the amount of matter stays the same. Okay, so that's not changing. Matter is being conserved. Alright, this video shows a plant growing, because this is often a question people have. What about a plant growing? Isn't matter being created here? And it really looks like it is, but if you think about it, you are what you eat. Okay, so this plant is eating in, it's eating water, it's having, food, and so because of all of this matter that's going into the creation of this plant, matter really isn't being created. It's just changing shape. So that soil, that water that is feeding the plant is changing shape. And so even when it blows up like this, we can see that matter's changing shape. It's changing shape into very small pieces. But if we were to add up all of the pieces that make up this exploding pumpkin, it would still equal the same amount of mass as the whole pumpkin. Okay, so matter's not being created, matter's not being destroyed, it's just in a lot of different pieces. Okay, so conservation of matter, conservation of mass still applies here. So a couple other examples. What if a paper airplane is made? Okay, this is a physical change. Physical change, we still have paper, no matter is being created, no matter has been destroyed, conservation of matter still applies here. But what if a log is burned? Then you're destroying matter, right? It looks like it. It looks like matter is being destroyed because the log vanishes. But if you were to light a log on fire in a sealed room, you would still have the same amount of mass, because that smoke and that ash are going to add up to the same amount of mass that log once was. So conservation of matter still applies. The amount of matter remains the same, even in a chemical change, which the burning of that log would be. Okay, last one. So this would be a level 4. Using the principles of conservation of mass, decide which is the correct product of vinegar and baking soda. Okay, so here this is the molecular formula for vinegar, and this is the molecular formula for baking soda. When we combine these two, what would you get? Would you get the chemical formula in A? Would you get the chemical formula in B? Or would you get the chemical formula in C? See if you can pause the video and figure it out. Alright, well, the product that it would be, we have to figure out how many of each element are in this molecule. So we have 1, 2, 3 total carbons. Okay, so carbon 3. We have 1, 2, 3, 4, 5 total hydrogens. Okay, 5 hydrogens. We have 1, 2, 3, 4, 5 total oxygens. And we have 1 sodium. Okay, so then we have to look at these different options. All right, let's look at this one. It has 1 sodium, good. It has 1 hydrogen, not so good. That's not going to work. How about this one? It has 1, 2, 3 carbons. Okay, that checks out. What about hydrogens? 1, 2, 3, 4. And we're supposed to have 5, so that's not going to work. Then it has to be this one. So let's see. We have 1, 2, 3 carbons. That checks out. We have 1, 2, 3, 4, 5 hydrogens. That checks out. We have 1, 2, 3, 4, 5 oxygens, and we have 1 sodium. So this has got to be our correct answer because we have the same amount of atoms in the ingredients as we do in the product. Okay, so using conservation of matter, you can figure out what the chemical formula is going to be of a reaction. Alright, well that's it. This is a quick goal. I don't think it'll take too long for us to get it, but if you have questions you can always ask, and please bring questions to class when you come back and we will talk about conservation of matter. Alright, that's all. Bye-bye.